Welcome students, welcome to this session. In this session, we are going to see about the steam and steam boiler. So in this session, we are going to see about the
This is the
classification
classification
of
of
boilers,
boilers.
part 1. Boilers are classified according to horizontal or vertical or inclined boilers. So if the axis of the boiler is horizontal, the boiler is called the horizontal, and if the axis is vertical, it is called vertical boiler, and if the axis is inclined, it is called inclined boiler. Then the fire tube boilers. In the fire tube boilers, the hot gases are inside the tubes and the water surrounds the tubes. Okay, so it is called the fire tube boilers. So if the tubes, uh, if the fire or hot gases flow through the tubes and the water surrounds the tube, it is called the fire tube boilers. Example: Cochran boilers, Lancashire boiler, and Locomotive boiler. And water tube boilers. In the main difference between the fire tube and the water tube is in fire tube the hot gases is flow inside the tubes, but in water tubes the water is inside the tubes and hot gases surround them. So for example, Babcock and Wilcox boiler and Yarrow boiler. So this is how it looked like. It's a furnace and the water is flows inside the tubes and it's surrounded by hot gas or fire. It is called the water tube boilers. So this is the main difference between the water tube boilers and the fire tube boilers. In water tube boilers, water flows inside the tube, it is surrounded by a furnace. And in fire tube boilers, the fire and hot gases goes through the tube surrounded by water. And the externally fired boilers. The boiler is known as externally fired if the fire is outside the shell. For example, Babcock's and Wilcox boilers. The internally fired boilers. In case of internally fired boilers, the furnace is located inside the shell. Examples: Cochran and Lancashire boiler. And the forced circulation boilers. So in forced circulation type of boilers, the circulation of water is done by a forced pump. For example, Lamont and Benson boilers. And the natural circulation boiler. In natural circulation type of boilers, circulation of water in the boiler takes place due to natural current, convection currents produced by the application of heat. So examples of for this type of boilers are Lancashire boiler, Babcock and Wilcox boiler. And there are high pressure and low pressure type of boilers. So the boilers which produce steam at pressure of 80 bar and above are called high pressure boilers. Example: Babcock and Wilcox and Benson boiler. Low pressure boilers. The boilers which produce steam at pressure below 80 bar are called low pressure boilers. Example: Cochran boiler, Cornish boiler, Lancashire boiler, and Locomotive boiler. Stationary and portable boilers. Some boilers we can use as a stationary, it means fixed, and some boilers it may be used as a portable or movable. So stationary boilers are used for power plants, steam, for central station utility power plants, for plant process steam, etc. So it means it is completely fixed in that one place. In mobile boilers or portable boilers include locomotive type and other small units for temporary use at the site. Then single tube and multi-tube boiler. Fire tubes boilers are classified as single tube and multi-tube boilers depending upon whether the fire tube is one or more than one. Example: Cornish. And simple vertical boilers are the single tube boiler and rest of the boilers are multi-tube boilers. According to the passes, it will be considered as a single pass or multi-pass. So let's see the images. This is how the Lancashire boiler. It is a horizontal boiler. This is how the actual Lancashire boiler looks like. We'll see this detailed the Lancashire boiler later in part 2 or part 3. And this is how the locomotive boilers looks like. Majorly it is used in train engines. In previous steam type of train engines, we are using this locomotive boilers. So this is how it looks like. And Babcock and Wilcox boiler. This is how this Babcock and Wilcox boiler looks like, and we'll study this also in 3. And this is a Lamont boiler. This is how it's look like. It's a fixed type boiler. It's a fixed type boiler. It is used in the power plants. And this is how the Benson boiler. This is also a fixed type boilers. This is how it look like. Now in this part 1, we are going to detail the study about this Cochran boiler. So it is a multi-tubular vertical fire tube boiler. Multi-tubular vertical fire tube boiler. having a number of horizontal fire tubes. So it is a modification of a simple vertical boiler where the heating surface has been increased by means of a number of fire tubes. So it consists of shell, grate, firebox, flue pipe, fire tubes, combustion chamber, chimney and manhole. So this is how the Cochran boiler will looks like. Okay. So the normal size of the Cochran boiler, the shell diameter will be 2.75 meter, and the height of the overall shell will be 6 meter. Okay. So this is what the grade. Okay. This is the grade. So it is placed at the bottom of the furnace where coal is burned. Here only the coal is burned, and this is the ash pit. And this part is considered as a shell. The topmost part is considered as a shell. It is hemispherical on the top where space is provided for steam. So where space is provided for steam collection. Okay. And this is the firebox. Okay. This round, it's considering it's a firebox. It is also dome shaped like the shell so that the gases can be deflected back till they are passed out through the flue pipe to the combustion chamber. So this is the combustion chamber. So it will be like a dome shaped so that the gases can be deflected back till they are passed out through the flue pipe to the combustion chamber. Okay. Next, this is the flue pipe. So it is a sharp passage connecting the firebox with the combustion chamber. So this is the combustion chamber, then this is the combustion chamber and this is the firebox. So this flue pipe, it is the shortest passage which connect the firebox from here to this combustion chamber. And this area is as a combustion chamber. It is lined with fire bricks. Okay, it is lined with fire bricks on the side of the shell to prevent overheating of the boiler. So these are the fire brick lining. Okay, that it can prevent the overheating of the boiler. The hot gases enter the fire tubes from the flue pipe through the combustion chamber. This hot gases from the flue pipe, it enters into the fire tubes. Okay, it enters into the fire tubes in the combustion chamber. So this is the fire tube. So number of horizontal fire tubes are provided, thereby heating the surface is increased. We are giving more number of fire tubes so that more number of surface heating will be. So next, this is the manhole, the short small curves of it. It is provided for inspection and repair of the interior of the boiler shell. And this is the chimney. So it is provided for the exit of the flue gases to the atmosphere from the smoke box. And this is the again the fire tubes. And this is how the actual Cochran boiler looks like. Okay. So now let's see the working of the Cochran boiler. The coal is fed into the grate through the fire hole and burned. So this is the grate. So through this fire hole, we are feeding the coal and we are burning the coal. So ash formed during burning is collected in the ash pit, just provided below the grate, and then it is removed. So the hot gases manually from the grate. Okay. So the hot gases produced from the grate is passed through the flue pipe to the combustion chamber. From this grate, the hot gases produced flow through the pass through the flue pipe to the combustion chamber. Okay, the hot gases from the combustion chamber flow through the horizontal fire tubes and transfer the heat to the water by convection. Okay, here the horizontal fire tubes are there. So these the hot gases is enter into the fire tubes. So it is surrounded by water so that the water is observing the heat through this fire tubes by convection. So the flue gas is coming out of the fire tubes. It's coming out of the fire tube, pass through the smoke box. This is the smoke box and are exhausted to the atmosphere through chimney. Okay, and it passes through the smoke box and are exhausted to the atmosphere through the chimney. The smoke box is provided with a door for cleaning the fire tubes and smoke box. And some Cochran boiler mountings, and some of the boiler mountings we are going to see for especially for the Cochran boiler. First one is the water gauge. This indicates the water level in the boiler. So water gauge indicates the water level in the boiler. The water level in the boiler should not fall below a particular level. Otherwise, the boiler will be overheated and the tubes may burnt out. So there is a much consideration needed to check the water level. It must not go beyond the limit. Go beyond means below the particular limit, or otherwise the boiler tubes will be get burned out. Then the blow of cock. This down part is a blow of cock. It is located at the bottom of the boiler. When the blow of cock is opened during the running of the boiler, the high pressure steam pushes out the impurities like mud, sand, etc. in the water collected at the bottom. Okay, so it is located at the bottom of the boil. By when the blow cock is opened, so during the running of the boiler, the high pressure steam drains out. Okay, which drains out the impurities like mud, sand collected in the bottom, and this is the pressure gauge. So this indicates the pressure of the steam inside the boiler. It's much needed. So it is which indicates the pressure of the steam inside the boiler. So second, steam stop valve. It regulates the flow of steam supplied to the requirements. So this only regulates the flow of steam. And the fusible plug. The fusible plug is here. It protects the fire tubes from burning when the water level in the boiler falls abnormally low. So this protects the fire tubes. In some cases, if the water level goes below the limit, it will protect the fire tubes from burning. And this is the safety valve. The function of the safety valve is to prevent an increase of steam pressure in the boiler above its normal. Now let's see the animation of how the Cochran boiler is working. Here in grate only we are giving firing happen. From this firing, the hot gas it flows to the flue pipe, and from the flue pipe to the combustion chamber, it's entered into the fire tubes, so that after the fire tubes it leads to the smoke box and to the smoke box to the chimney. In this combustion chamber, from the fire tubes, the heat is transferred to the liquid through convection. Okay, so that the heat water is converted into steam, and the steam is collected in this shell and go up for the requirements. So this is how the Cochran boiler is working. Let's see the saline features of Cochran boiler. The dome shape of the furnace causes the hot gases to deflect back and pass through the flue. So the unburnt fuel, if any, will also be deflected back. So the spherical shape of the top of the shell and the firebox gives higher area by volume ratio. So it occupies comparatively less floor area and is very compact, this Cochran boiler. So Cochran boiler is well suited for small capacity requirement. Thank you students. We'll see the next types of boiler in the next session.